Mbali, did we finish review yesterday? It's your turn. Okay, number 3b is 7x plus 9 equal to 3x minus 7. So read the next line to me. Thank you, that's perfect. Okay, if those of yours are swapped out, it's fine. It's the same thing there. Okay, Mbali, what's 7x minus 3x? What's minus 9 minus 7? Negative? Negative 16, that's correct. How do I get the 4 alone now? Divide both by 4 and then your answer is going to be? Thank you. That's the way I want it to go. Now, Lydia, see? 2x minus x? Negative 11 plus 5. Perfect. Okay? X equal to negative 6. Now, please just give me a second here. If you say 2x minus x is equal to 1x, then x is also alone. Okay? Remember, an apple or an apple and one apple, it's the same thing. Okay? There's no difference there. So if you got to 1x equal to negative 6, then you are also done. You don't divide with 1 or something like that. E, Bukang? Very good. Who got it right? X equal to 3. Well done. I just want to show you here. If you took it to the other side. Oh no, this one, I didn't do it with this example. That's fine. Sorry. Thank you. X equal to 3. Alright, next up, it's going to be F. Kurapetse. Okay, this is the one where the other class did it differently. 3x plus 8x equal to? Minus 12 minus 3. What is negative 3x plus 8x? Negative 15, yes, and then? Divide both sides with 5 and x is equal to? To negative 5. Ach, negative 3. Thank you. Sorry. Okay. Who got it right? X equal to negative 3. Well done. Here is the one where they did it to the other side. So in the other class, they took the negative 3x over, it became plus 3x. So this is the one that is also fine. You get to the same answer. But as I said, I personally prefer having the coefficient be positive. Okay. But if you didn't do that, then you just got to negative 5 on the right-hand side and 15, a positive 15. And then when you divide with negative 5, you also end up with negative 3. Okay? Do you all understand? Okay, and next up is going to be H. Well, we got Leo. 18 plus 9 equal to 5x minus 2x. That's perfect. Yes. X equal to 9. Perfect. Here again, they chose to take it to the other side and they had to work with lots of negatives there. Okay. The more negatives, the more chances to make a mistake. Where are your glasses? Yeah, take them out. X is equal to 9. Who got this one right? 9? Good job. Okay. Now, lady. Okay. Very good. There's the other way around as well if you took it to the negative sides. Who got the answer? X equal to 7. Okay. What's going on with Kaylin? And who else whose hands are not going up? No. Pamu? Do you guys understand? You're going to have to redo this activity if you're getting all of them wrong. Kaylin? Then we have to go to number 4B. Who got all of them right at number 3? Good job. One mistake? Good. Anyone that has a question on it? All fine. Okay, Kaylin, 4B.
So I said 4x minus 4 is equal to 16. And 4x is equal to 16 plus 4. And then 4x equal to 20 and divided with 4. And 4x divided by 4. And then when we divide by 4, x is equal to 5.
Good job. Then we go to C, Ayanda. Good job. We got it right. Y equal to negative 7. Well done. Okay. Really? Perfect. Well done. Okay, then we're going to have to go to D. Number 4D, because that's the one we didn't get to during class, ne? The examples. Okay?
6x plus 2 equals negative 10. 6x equals negative 10 minus 2. 6x equals to negative 12. Divided by 6, we will say x equals to 2.
Well done. You got it right? Okay. Then we go to E. No. Just it's 3B minus 11 equal. No, we did that one, eh? Sorry, F. Right? 6x. Good job. Got it right. X equal to 8. Well done. Solofelu. H. Wait. Where are we now? G. Okay, so I have to page back. Sorry. Okay. Yes. Okay.
8a equals to 40 and divided both sides by 8 and 8 equals to 5.
A is equal to 5. Good, we got it right. A equal to 5. Well done. H. Redsang.
I say 14x plus 25 equals negative 7. 14x minus negative 7 minus 35. I say 42 over 14 divided
Okay, just hang on. 14x is equal to what?
equals to 42 minus 14.
42.
Yes, ma'am.
Okay, but look here, it's minus 7 minus 35. So you owe the bank 7 rand, you go and borrow another 35 rand. It doesn't become positive. When do two negatives become a positive? With what calculation? Who can tell me? Times. This is not multiplication. This is addition and subtraction, Retsang.
Yes, ma'am.
So minus 7 minus 35,
9 equals negative 42.
it will be negative 42. Okay. So you see, don't let the integer calculations make your algebra wrong. Right, and then we divide with 14 on both sides.
Equals 3.
Okay, but now it's negative 42 divided by 14.
Equals x equals 3.
What's a negative divided by positive?
Or negative.
Negative 3. Okay. You see integers catching up at algebra. You must learn your rules. Okay, Nikita?
I said 8b minus 4 equals to negative 28.
Mm-hmm.
And I said 8b equals to negative 28 plus 4.
Good.
And I said 8b equals to negative 28 plus 4. 8b equals to negative 24, and I divided them both by 8.
Yes.
Equals to b equals to 3.
Okay, negative divided by positive?
So negative.
Negative, so don't forget that negative 3. Okay. You all fine with that? You got all of them right? Everything? Good. 1 mistake? 2 mistakes? 3 mistakes? Any questions? All fine. Okay. Now we are still working with algebraic equations. We're going to look at two different parts as well. You can just write a heading. You can see I have cut my page in half. I just want, even if you just use a pencil, just draw a line in halfway through the page. I just want to do two different types of sums so that you can see the difference. Okay, so we're looking at algebraic equations when we have exponents and roots. Okay, so the one type of examples we're going to look at is when the variable is in the exponent, and the other one is when the variable is in the base. Now the one where the variable is in the exponent, you've actually already done these type of sums when we started with the equations. Do you remember these ones? We had them just without the calculation. In the first activity, it was 3 to the power of x is equal to 9. Then I told you can do it in the guessing way or in the way that you're going to do it in grade 10 and 11 and 12. And I told you that would be a level 4 sum that we come across in the exams, and that there would be an activity where we have these type of level 4 sums in it. Okay. Is there anyone who can remember and can tell me what I told you what we must do with that first activity when we've got the exponent there as a variable? What must we do with this right hand side with 9? How can I rewrite it? Because that's where we're going to start. Okay, we write this as also in exponential form, né? With the base the same as this one. In this case as 3. So I have to change 9 to be 3 to the power of something. And it will always be able to be written as this base to the power of something. So tell me, grade 8, what can 9 be written as? 3 to the power of 2. Now, can any of you remember what do we do once we have these bases that are the same? What do we do with the bases when they are the same? Now, Lydia, you want to tell me? Can't you remember? We throw them away. Okay, we throw them away. We just don't write them any further, because that's something that you will learn when we work with exponents in grade 9 and 10, that once the bases are the same, no more calculations will happen in the base. All of the calculations will be done in the exponents. If you think about it, when we did exponents and we had 3 to the power of 2 times 3 to the power of 5, what was the first rule of exponents? If the bases are the same, the bases stay the same and you add the exponents. So we don't calculate with the bases once they are the same. Okay? So now we can throw them away and we just write what we have in the exponent. And do you see now the sum looks like the ones that we are used to? We still just need to get x alone. So to get x alone, I need to take that plus 1 underneath the rainbow to the other side. What's it going to turn into on the other side? Minus 1. What is 2 minus 1? 1. And there you have it. Do you see here again? The variable is in the exponent. So our step 1 would be to write the 32 as what? 2 to the power of something. Okay, we will see what that something is now. This side we leave as it is because we need to get the bases to be the same. Now if you don't know, then you use your calculator or you use your head. No? Let's start. Use our heads. 2 times 2 is? Times 2 is? Times 2 is? Times 2 is? 32. And I saw many of you were showing me 5 already before having to calculate it. It's 2 to the power of 5. And when my bases are the same, I throw them away. So I have the sum 2x minus 1 equal to 5. Do you see this looks like a normal easy solve for x sum? Which one am I going to take over first? Because remember, we still just want to get x alone. Am I taking the 2 or the minus 1? Minus 1. And what does minus 1 turn into? So I've got 2x on this side, and 5 plus 1 is 6. Now, how do I get rid of the 2? Divide by 2 on both sides, and x will be equal to 3. And let me just show you how it works. You can always test your answers once you've calculated them with an equation. You are saying the answer is 3. 2 times 3 is 6 minus 1 is 5. 2 to the power of 5 is 32. Okay. Right. These are the ones that we have seen a bit. Okay? Now we're going to look at the sums where the variable is the base. Now this is actually a lot easier even, but the main thing, and this is why I did them next to each other, is for you to know when it's which one. Okay. So this one, the exponent is the variable. Now the base will be the variable. In all of these sums, when we were adding, subtracting, multiplying and dividing, and even here with the bases, variable and the exponent, we were trying to get the variable alone. That is still what we want to do. What is preventing this x from being alone? That square. Okay? Now when we add the sum where we had something like 2x equal to 10, we said we are going to do the inverse calculation. We do the inverse when it's stuck to it, like when it's in one term. Here it's one term. The 2 and the x is in the same term. Here the x and the square, it's in the same term. There's no plus or minus separating them. Okay, so we said we do the inverse calculation. What's inverse of multiply? Divide. And then we did it on both sides. The 2's cancel out, and I had x equal to 5. That basic rule still stays the same. But now, just quickly tell me, recap and get a new one. What is inverse of plus? Inverse of times? Inverse of square? Square root. No? Okay? So what I'm going to do to get rid of that square is I will put a square root over it. Because a square and a square root will cancel each other out. Do you agree with that? 5 squared square root will still be 5. Because 5 squared is 25 and the square root of 25 is 5 again. So they cancel each other. But if I put that square root there, what's happening to my scale? It's tipping. Because I just put something there. What must I do to get it level again? Do the same on the other side. So on the left hand side, I have x alone. And on the right hand side, I have 7. Okay. But now here's another trick that you have to remember. This answer will be 7 or negative 7. Do you agree with me? 7 times 7 will be 49. Negative 7 times negative 7 will also be 49. And if you don't write both answers, you will lose marks. Okay. So when I have a square like this, that means there are 2 answers. Okay. Now, this is not the first time we've seen the square root of a number in mathematics. Do you agree with me? Or during this year? So I did it here on the board, but I'm going to do it on the book for you as well, because we're recording so everyone can see. The rule is, when the square root, like that square root 49, is part of an expression. Do you remember an expression? That's the one that doesn't have an equal to sign. When it's part of an expression, you only write the positive answer. But when it's part of an equation, you have to write both of the answers. Okay? Example. When we were in the second and the first term, you had a sum that might look like this. What is this one I wrote down? 3 minus the square root of 16 times 2. Okay? This was an expression. Do you see there's no equal to sign? You just had to simplify. So what you would have done, you would have put the equal to sign nicely on the left-hand side like I taught you, ne? 3 minus 4 times 2. You see you only gave the positive there. Then you had to apply BODMAS and do the multiplication first, and it gave you 8. And then in the final step you would do the subtraction. 3 minus 8 is going to be negative 5. Okay, that's an expression. You only write the positive answer of the root. But if it's like now when we have an equation x squared equal to 16 and I'm taking the square roots on both sides, there's the equal to sign. It's an equation. We are asking, what can the value of x be? Then you have to say x can be equal to positive or negative 4. And you can write the answer like this, plus minus 4, or you can write it like I did there, 7 or negative 7. If you write it like this, positive or negative 4, just understand that it's not plus minus 4 like roundabout close to 4. Okay? It is positive 4 exactly or negative 4 exactly. Not plus minus roundabout. You understand that? Okay. So, let's just recap on the sum. First thing, you have to identify that the variable is in the base. Okay? That's the one where we do the inverse of a root. When you take the square root, it cancels and you have to do it on the other side. And then when you write the answer, there will be 2 answers. And I can assure you that in all of the departmental question papers of the past few years, they have put the sum in there where you have to give both answers, because most of the grade 8s forget, they only write the one answer. So if you've got like these little labels, you know those labels that you put at the side of your book, then I suggest you put this here, because it's only this one activity that we have where we see this. Okay, we don't really see it at any other places. So remember this. Let's do another example here. You remember I told you that we are actually doing BODMAS backwards, no? That's still true. And I also said it to you in another way. I said we always start by taking the one that's furthest from the x. So that square is part of x. It's in the same term. That 3 is further from it because it's in another term. Right? So, having said that, if I ask you, which one will we take over first? Which one will it be? The plus 3. Okay. And let's just think about it logically for 1 minute. If you were to take the square root here, you would have to take the square root over the whole thing, and you cannot take the square root of x squared plus 3 because you have to do the plus first. So you see that plan cannot work. The second problem with doing that, if you take the square root on the left side and you take the square root of the right side, 28 is not a perfect square. And they are definitely not going to give you a sum at this stage in grade 8 that won't be a perfect square. Okay, it should be a perfect square. So, can we all agree we're definitely taking the plus 3 over first. So I'll be left with x squared equal to 28 minus 3. So I've got x squared equal to 25. Now x is almost alone, but not quite yet. What must I do to get it to be alone? Square root, then it cancels out. And now my scale is tipping. Also on the other side. Now please tell me, my clever grade 8s, what is this one's answer going to be? X equal to 5 or negative 5, or you can say plus minus 5. And that's it. Now I want you to practice it. All of the sums will either be variable in the exponent or variable in the base. It's on page 118. I will put it on now. Let everyone just finish writing. Page 118, right at the bottom, activity 9.3. There are 12 of these sums. As you see, x in the base at number 1. X in the base at number 1. There I want you to think, are you going to take over the square or the 3 first? Remember, when you square root, it has to be over the whole thing. Can you take square root of 3? Can you take the square root of 3? Okay, so that will give you a... Is yours different? Yes. I knew there was one textbook. I thought it was the Afrikaans. Okay, your order is just different, but it's fine. When we mark, you will tell me. Okay, but look there. Which ones has the x in the base and which ones has the x in the variable? And then you know what you have to do. When the x is in the exponent, you get the bases the same. If the x is the base, then you just do the inverse. Okay. You guys can start there.